My dear students, we are going to learn important points of chapter Haloalkanes and Haloarenes of CBSE 12th. In today's class, we are going to highlight some of the important points and topics which are very important for coming NEET and entrance exam. In the chapter's first page, they have mentioned about a chlorine containing compound called chloramphenicol, which is used to treat typhoid disease, and another halogen, that is iodine, which is present in our hormone called thyroxine, and its deficiency is going to cause goiter. There is one more chlorine containing compound called chloroquine, which is used to treat malaria. And they have also mentioned about a compound called halothane, which was used as anesthetic during surgery. If you see in the second page, the very important point is about allylic halide. In allylic halide, what happens? The halogen atom is bounded to sp2 hybridized carbon atom, that is next to carbon carbon double bond. I'll repeat once again. In allylic halide, the halogen atom is bounded to sp3 hybridized carbon atom, but next to that sp3 hybridized carbon atom, there is a carbon carbon double bond. In the next page, we are going to learn about vinylic halide. In vinylic halide, the halogen atom is bounded to sp2 hybridized carbon atom. Okay, sp2 hybridized carbon atom means having carbon carbon double bond. And also in this page, there is one compound called sim tribromobenzene. Its IUPAC name is 1,3,5 tribromobenzene. In the classification, there are two more haloalkanes which are quite important to the exam, that is about gum dihalide and vicinal dihalide. In gum dihalide, what we can find, the two similar halogen atom are bonded to the same carbon atom, whereas in vicinal dihalide, the two similar halogen atoms are bounded to the adjacent carbon atoms. So if you see the nature of carbon halogen bond, the nature of carbon halogen bond is polar. Why? Because of electronegativity difference between carbon and halogen. As we know, halogen is more electronegative than carbon. That's why the carbon halogen bond is polar in nature. In the coming page, we are going to learn about the two halogen exchange reaction. One is Finkelstein and another one is Schwarz reaction. In Finkelstein reaction, there will be a preparation of alkyl iodide from alkyl chlorides or alkyl bromides with sodium iodide and dry acetone. Whereas in Schwarz reaction, there is a preparation of alkyl fluoride from alkyl chloride or alkyl bromide in the presence of metallic fluorides. In textbook, these are the example for metallic fluorides which are used in the preparation of Schwarz reaction. If you see the properties, one of the important property of haloalkane is the boiling point. If you take the isomers in isomeric haloalkanes, the boiling point is going to decrease as there is an increase in the branching. So among these three primary, secondary and tertiary haloalkanes, isomeric haloalkanes, we can find that 2-bromo 2-methyl propane has the lowest boiling point. As the branching increases, the boiling point decreases. And if you think about the dihalobenzenes, para isomers has high melting point because of its symmetry. They fits in the crystal lattice better. Then if you learn about the ambident nucleophile, the meaning of ambident nucleophile means the groups like cyanide and nitrites, they have two nucleophilic centers, so they are called as ambident nucleophiles. If you take cyanide, if the linking occurs through carbon, there is a result in the formation of alkyl cyanide. And if linking occurs through nitrogen, it is going to form isocyanide. Similarly, in nitrite also an ambident nucleophile. If the linkage occurs through oxygen, then it is going to form alkyl nitrite. Alkyl nitrite. If the linking occurs through the nitrogen, then it will be a formation of nitroalkanes. Nitroalkanes. So this is about the ambident nucleophile. In the next page, there are, as you know, there are two important mechanisms, SN1 and SN2. Both are nucleophilic substitution reaction, whereas in SN2, which is a bimolecular nucleophilic substitution reaction, where methyl chloride and OH minus nucleophile when react, after substitution there will be a formation of methanol, and it is a second order reaction because the rate of the reaction depends upon the concentration of both the reactants. That's why it is SN2. And in SN2, after SN2 reaction, we will find there will be an inversion in the configuration, change in the configuration. And in SN2, we can find that the least reactive alkyl halide is tertiary halides are least reactive to SN2 because of the presence of bulky groups in tertiary alkyl halides. They are less reactive, whereas in SN1 substitution by unimolecular substitution nucleophilic substitution reaction, it is going to carried out in the presence of protic solvents. The example for protic solvents we have water, alcohol, acetic acid. And here we can see tertiary butyl bromide on reacting with nucleophile, there will be a formation of tertiary butyl alcohol. And in SN2 SN1 mechanism, the rate of reaction depends on the concentration of only one reactant, that is alkyl halide. So in SN1 reaction, the step 1 is the slowest step, which is reversible, where you can find the generation of carbocation, and slowest step is always a rate determining step. Remember, the slowest step is a rate determining step. And why does tertiary alkyl halides undergo SN1 reaction? Because they are going to form a stable tertiary carbocation in the first step. That's why tertiary alkyl halides always react through SN1 mechanism. Whereas allylic and benzylic halides, they show high reactivity to SN1 reaction. Why? Because the carbocation generated in both the case, are going to stabilize due to resonance. Now if you see the optical activity, and here you can find some important points, there are certain compounds which can rotate the plane polarized light, and such compounds are considered as optically active compounds. And optical activity usually measured by one instrument called polarimeter. The compounds which rotates the plane polarized light in clockwise direction, they are called as dextrorotatory, designated by D form or the positive symbol. Whereas the compounds which rotates the plane polarized light in anti-clockwise direction, they are considered as levorotatory compounds designated by L form or negative form. Such compounds are called as optical isomers, and phenomena is known as optical isomerism. And in another page, we are going to learn about asymmetric carbon atom or stereocenter. Stereocenter or asymmetric carbon atom means if all the substituents attached to the carbon atoms are different, then the carbon is said to be asymmetric or stereocenter. Another important point in this page is the objects which are non-superimposable, to each other, they are said to be chiral. The property is called as chirality. The example for chiral compound is butane 2-ol, where you can find the carbon is linked to 4 different groups. So other example for chiral compounds includes 2-chlorobutane, 2,3 dihydroxypropanol, and 2-bromopropanoic acid. These are some of the examples mentioned in the textbook. Let us learn about the meaning of enantiomers. Enantiomers are also stereoisomers, which are non-superimposable mirror images. Another important topic here is racemic mixture. Racemic mixture means equimolar mixture of both dextro and levo compounds or two enantiomers designated by DL or plus minus symbol both. And racemization means it's a process of conversion of enantiomers into racemic mixture. Enantiomers into racemic mixture is considered as racemization. So here, when alkyl halides reacts with metal like magnesium or any other metal, they are going to generate organometallic compound. It was first discovered by Victor Grignard. That's why it is commonly called as Grignard reagent. And Grignard reagent general formula is RMgX. In RMgX, the speciality is in the Grignard reagent, the speciality is carbon magnesium bond is covalent and highly polar, whereas magnesium halogen bond is ionic. That is the nature. And if you see, aryl halides are extremely less reactive towards nucleophilic substitution reaction because of resonance effect and because of the carbon halogen partial double bond. The carbon halogen partial double bonds in aryl halides, it is difficult to cleave that bond. That's why they are very less reactive towards nucleophilic substitution reaction. In polyhalogen compound, one of the polyhalogen compound is dichloromethane, which is used as a solvent in paint remover. One more is trichloromethane or chloroform, which is used as used to prepare Freon's refrigerant R22. Freon refrigerant R22 is prepared by chloroform. And chloroform slowly oxidized in air in the presence of light to produce a poisonous gas called phosgene. Phosgene chemical name is carbonyl chloride. In order to protect chloroform, we need to store in dark closed dark colored bottles. Another polyhalogen compound is iodoform, that is triiodomethane, which was used as antiseptic. And tetrachloromethane or carbon tetrachloride, it is used as a feedstock for the preparation of chlorofluorocarbons, that is freons. So as you know, the freons are responsible for the depletion of ozone layer. When the ozone layer depletes, UV light falls on the skin and leads to cancer and other disorders.